Hi guys, welcome to another video of physics. In this case, we're going to see how to represent a vector, and we're going to see only two ways: the polar coordinates, this one over here, and the rectangular components over here. So let's explain first the polar coordinates. Okay, let's imagine that I have a vector. Let's change the color. Vector. Okay. In order to represent a vector using polar coordinates, we need a magnitude, and also we need direction and direction. So, for example, one way to represent a vector using polar coordinates would be the velocity vector equals 10 meters per second at 152 degrees. Okay, so once you see this representation of a vector, that means that that vector is written using polar coordinates. Now there is something very important, is that this number over here is always positive, always, because the direction, positive or negative, is given by the angle. So this number is always positive. So with this direction, we're going to see if the vector goes to a positive direction or a negative direction. Okay, so that's why we say that the magnitude of this vector is always positive. Okay, but what about the rectangular components? Okay, so let's see over here. Rectangular components. Now I'm gonna say that every vector has two rectangular components. I'm going back to that explanation, to what I said about it in a moment. But those rectangular components will be Bx, and this is the x component, and this is the horizontal component, horizontal. Okay, and also we're gonna have By. This is the y component, and this is the vertical one, vertical. Okay, so I'm gonna explain these two guys, but I'm gonna do it over here. Okay, so let's say that we have that vector, I don't know, the velocity vector, that is 10 meters per second at 60 degrees. Okay, then what I'm going to do, I'm going to draw it, and I need the Cartesian plane. So I'm gonna draw a single Cartesian plane like this, just like this. And I'm not gonna fill it with all the information. I'm just gonna say that this is X and this is Y. This is 0 degrees. This is 90 degrees. Sorry. And this is 180 degrees. So the vector, this vector, it says that it's at 60 degrees. So it must be between 0 and 90. So the vector must be over here. Yes. This is the vector, the velocity vector, and this is the angle or the direction. Remember that we are going to use the letter theta in order to represent the direction. But as I said before, every vector, no matter what, has two rectangular components. Well, that is because we are talking about 2-dimension. If it will be 3-dimensional, well, it's going to have 3 rectangular components or cubic components. But in this case, it's going to be only 2 because it's 2 dimensions, x and y. So the rectangular components are going to start exactly the same from the origin. So this vector has one horizontal component over here. This is bx, and this is by. I said before, and I said it again, every vector has two rectangular components. Now, bx, I mean, I'm not drawing this line going to the left because the vector, this vector over here is pointing to the right. So that's why I'm going to draw bx, the rectangular x component, facing right. And also it happens the same thing with by, goes up because this vector is pointing upwards. Okay, next what I'm going to do, I'm going to draw this vector again over here. Imagine that this is the beginning, the start of the vector. I mean, in this case, I'm not going to draw the Cartesian plane. This is the vector over here. That is b. And then I'm going to draw bx. This is bx. And then what I'm going to do, I'm going to move this vector and I'm going to put it here after bx. That's a property of the vectors, that you can displace them anywhere that you want. But I mean, you just can move it. You cannot modify them. It's just like I'm going to drag the vector and I'm going to put it here. But I'm not going to change the direction or something like that. Got it? So I'm just going to move it and I'm going to put it here. Okay? So this is bx and this is by. And if you see, now we have, and this is the angle over here. And if you see, now we have a right triangle that has a 90 degrees angle. So if we have a right triangle, we can use trigonometric functions. So there is a function that says something about the opposite and the hypotenuse, and another function that says something about the adjacent and the hypotenuse. So for example, I'm going to write this. The cosine of the angle equals the adjacent side, that is bx, over the hypotenuse, b. And the sine of the angle equals the opposite side, that is by, over the hypotenuse, that is b. Okay, so from these two formulas, I'm going to isolate bx, and from this one, I'm going to isolate by, because I need to find them. I need to find the formulas for those components, and I need to write them here. So for this case, the only thing that I'm going to do, I'm going to move the vector over here, and I'm going to move it over here. Multiplying, in this case, is dividing, goes this way, goes multiplying, and it's going to happen the same thing with this formula. Is dividing, so goes multiplying. So the formulas that we're gonna have is the vector, the rectangular component x, equals the magnitude of the vector. In this case, I'm going to raise this little arrow over here, because remember, the arrow means that I'm going to write the magnitude and the direction. But in this case, I'm just going to use the magnitude. The direction is given by the cosine of the angle or the sine of the angle. Okay, so bx equals the magnitude times the cosine of the angle. And by equals the magnitude of the vector times the sine of the angle. And these two are the first two formulas that we are going to use during the course of physics, during the whole videos that we are going to see in this course and in this playlist. Got it? Okay, so I hope I made myself clear that there are two ways to represent a vector, using polar coordinates and using rectangular components. And these formulas that I write here, well, we count these formulas using this and using the right triangle representation and using trigonometrical functions. Got it? But if you don't want to get trouble with the information and memorizing formulas and all the procedures, I mean, this is only the two formulas that we are going to need. In the next video, we're going to see how to transform a vector using polar coordinates into rectangular components. Okay, well, see you in the next video, guys. Bye bye.